positive. So there are lots of things that might not look like power functions at first, but actually are. Because 1 over x, it has been decided, is equal to x to the negative 1. And when you see this negative exponent, what that's going to indicate is that something is unhappy where it is. So if I had 1 over x squared, like if I had 3 over x squared, that would be equivalent to, now the 3 is okay. The 3 is not unhappy where it is, but the x is. So 3 times x to the negative 2. Both of these would be examples of power functions that have negative exponents that may not look like it at first. And this is not derivative. This is just algebraic rewriting. A lot of times people, when they see something change, assume that we've taken the derivative, but we have not. We have not taken the derivative. We've just rewritten it in a different form. So that's an important thing to emphasize here. Is there anything that says I can't take the derivative using a negative exponent? No. The power rule applies to power functions regardless of whether the power function, the power rule applies to power functions regardless of the exponent, as long as it's actually a power function. So if I look at something here like f of x equals 3 over x squared, my first step is to rewrite this using algebra. Because even though it is a power function, it's not in a function where it's not in a place where the power rule can apply for me yet. So I'm going to rewrite it first using algebra as f of x equals 3 times x to the negative 2. Now that it's set up in power rule form, now I can take the derivative. I don't like using capitals. It looks like I'm screaming, so I'm going to put now a bunch. Now I can take the derivative, and the rule says I should leave the constant in front alone, bring down that negative 2, and subtract 1 from. So this is 3 times negative 2 times x to the negative 2 minus 1. Now I might decide I don't like the way this is written and think it could look prettier. But before I do that, are there any questions on how we've taken the derivative of this power function that involved a negative exponent? Now I'm going to probably want to clean this up as f prime of x is equal to negative 6 times x to the negative 3. And if I wanted to, I could even rewrite that one more time as f prime of x is equal to negative 6 over x cubed. Because this negative exponent wants to go somewhere else. It wants to go down to the denominator.